Welcome everyone. We are going to have a very interesting discussion about physical activity measurements with accelerometers and data analysis, especially with GGIR software. And we have a great expert for this episode. He has done his PhD at University of Granada in Spain. Currently, he's working as a postdoctoral researcher at Linköping University in Sweden. He has published impressive body of work related to accelerometry, physical activity, and its relationship to cognition and brain anatomy. Ladies and gentlemen, please welcome our guest, Dr. Jairo Hidalgo Migueles. Welcome.
Thank you so much. Thank you so much, Ali. So happy to be here. I've been listening to some of your podcasts, and they are really interesting and really motivating for all of us. So thank you so much. So happy to be here.
Yeah, nice to have you. And I've been sometimes in Granada, and I think I read that there's more than 360 sunny days on average per year. And now you are in Sweden. How do you like the weather?
Well, that's a good question. I don't want to get into troubles here in Sweden, so I will say that the weather here is amazing. It's the best thing I could experience at the moment. But sometimes I miss Granada. I will also say that.
Yeah. It's a very nice city, historic, and the weather is nice. So you have been doing quite a bit of work with accelerometers, data analysis, and physical activity, and you have worked with the GGIR. Could you tell the basics of this software, the package, to listeners who have never heard about it?
Yeah, so basically GGIR is a software that is mainly developed by Dr. Vincent Van Hees, and I'm a collaborator, so I'm helping him to maintain and to develop some functionalities in the software. And it basically, well, it's an open source software, so anyone can get into the code, into the script, anyone can collaborate, anyone can develop functionalities in their own, or they can get in contact with either Vincent or with me to work on the software development. So it's alive. It's always increasing in functionalities and so on. And basically it focuses on getting the raw data of different accelerometer brands and applying some algorithms that are validated in the literature. And then using these algorithms, we will get our estimates of physical activity, sedentary behavior, sleep, and some other interesting outcomes.
So anyone can develop, and you have been a collaborator. Which parts have been your responsibility?
Well, at the moment we are, I've been fixing bugs of the software. I've been adapting the code to different projects that I have needed it to work in. I have also worked in the time use management within the software to really differentiate the different parts of the day. And I've been applying some code to get some different metrics like the mean amplitude deviation and some other metrics that I found interested in the literature, and I would like to use them in my studies. So I asked Vincent if he will be okay if I include this code within GGIR, and he said yes. So I've been working on that in the last years. And right now I'm mainly in contact with him. So we have the code open in GitHub, and there we post every issue, everything we think that the code might be improved in, and we just split the job between the two of us and try to develop it further.
And how many people have been developing the code? How big has the group been in total?
Yeah, well, I don't have the answer in the top of my mind at the moment, but many people have helped to the maintenance and developing of the software. So actually, in the package.net, I can send you the link later on. There is a list of all the collaborators, so all the names are there. I don't want to tell you an answer because I will be wrong for sure.
Yeah, but anyway, it's a lot of people who have developed it, and
Yeah.
you said that it's for the raw data and it analyzes sedentary behavior and physical activity. What where locations do you have as an options?
Yeah, so our main goal in GGR is that it's not adapted specifically to a specific location. So we accept data from any location, and we have. So this will affect. At the moment, GGR is mainly adapted, at least for the sleep quantification. It's mainly adapted to the wrist location, but there are options to use it in the hip. So I have used GGR mainly with hip and wrist data because this is the data I've been working with in the past. But you can apply as it is an open source code, you can include your algorithms there and you can develop anything that you need for a specific work location. So, no, mainly the cut points, you will need to adapt the cut points to the different locations, and the sleep assessment is maybe the part that is more adapted to wrist within GGIR.
So how is the software working? What kind of skills do you need to be able to use it?
So we try to keep it as simple as possible. So the software runs in R at the moment. So at least some familiarization with R will be good, but not too much. So the whole functionality of the code is in just one function, and the only thing you need to know is how to use one function in R and how to define the different parameters or the different arguments that you need to get the data as you wish. So you just need to define, for example, when is the accelerometer recording starting or when it's finishing, if you would like to process the whole data or maybe you want to skip the first and the last day. And you will need to say what algorithms do you want to use, what cut points do you want to use. And this is done in just one function. So you don't need great skills to great coding skills to use GGIR. You just need to install R and R Studio in your computer and then get familiarized to it for a bit, and then you are all set to use GGIR.
And I think we probably have quite many listeners who don't use R or cannot code.
Yeah.
How do you see the learning curve? Should they contact someone? Should they find somebody to their team? Or how much should they spend time learning to use it if they don't have any experience in coding or R?
So thus far, Vincent has been doing some training in GGIR, specifically for some research groups. So this is one option that they contacted Vincent through his webpage, and he will be very happy to do the training sessions for them. And beyond that, we are now preparing some more training opportunities. So this will be, you need something very specific for your group, but we're also preparing some training opportunities to a more broad audience. And we're just starting to prepare the contents of this course and all the practicalities. But we hope that we can start running them in autumn this year. So this will be an option to get into GGIR and get to know how to do it. In the meantime, you can always go to the package BigNet, and there you have the very basic instructions on how to use GGIR. And just reading that, you should be able to at least get some basic estimates from your data.
So interesting. You are starting a course. How do people find more about the course and what is the format? How much does it take time?
We are right now deciding on that. So there is no information yet online anywhere. It will be soon, but not yet. So at the moment, if anyone is interested, they can contact us and ask some questions, but we don't have a definite answer on how it's going to be. We know that it will very likely to be online. And we're just deciding on anything. So anything I say here may change in the future, and I don't want to make a mistake. But it will be more information soon online. We will start promoting the course very soon.
All right, you can send also some info to me. I can maybe advertise it in some podcast episodes so people can find it then. So what do you see as the biggest advantages of GGIR? I think the good thing is that it's open source. How do you see it as the biggest advantages?
This is one for sure that is open source, and you know what is happening with your data. I mean, in terms of research, I think this is very important because it improves the comparability of the code, the reproducibility. Uh, I mean, you know from the very start to the end of the process what is happening in every step. If you want to, you can get into the code and see what is happening with every chunk of data that you load. And apart of that, a great advantage I see and that I have used in my research is that as you know what is happening with the data, if you get data from different devices and you apply the same algorithms to that data, you can still get very comparable, very close estimates from different devices using GGIR. And I think that's a big advantage. Because sometimes people are really worried about what accelerometer should I use, and at the very end, if you use similar processing methods as we do in GGIR, you will get similar outputs from the different brands.
Hmm.
And so that will be the main advantages for me, the data comparability and that open source, and that everything that we apply in GGR is validated in the literature. So that's also very important
Hmm.
for us.
So what you said is that it doesn't really make a difference which brand you are recording the data if it's recording raw tri-axial accelerations with high enough frequency. It's just about what you do afterwards.
Of course, there can be small differences based on the hardware or based on the devices that you use and the size, the weight, everything can produce small differences. But my experience, I have used some different brands in GJR. My experience is that I got very close estimates.
Hmm. Yeah. And what do you see as other options to GGIR? What other options there are if you don't want to use specific brands and their analysis algorithms?
Well, there are many options. Uh, I think, well, I don't remember the name of the different software right now, but there are many people who are developing open source code for processing accelerometer data. Uh, I know Paul Hibing in the US was developing some code with ActiveGraph. I know that people at Oxford University, the Aiden Doherty group, they are doing a great job also with their tools to using machine learning on accelerometer raw data from the activity device, and they are doing also a good job there. I think the ProPass consortium also has a software that can be used in different brands, and that's also really interesting. So I don't remember right now the name of the
Hmm.
different software, but I know there are many of them, and that's good for research. I mean, we need more people developing and more people proposing algorithms for our data. That's always good news for us.
Hmm. So how do you see the future of different software sets? I think there's a lot of options, but should you collaborate together to have them in one package, or how do you see what would be the ideal case in the future?
I think we always want that unique answer for everyone, like the one for all. But I think that's not possible because I mean every group, every project has their own research questions, and they will have different needs, and so I don't think our goal should be looking for the perfect software. I mean, we all have something to do here, and different software can provide compatible estimates or compatible data. And I mean, I'm not really worried about just using one software. I will use whatever fits better my needs in every moment.
Hmm. Yeah, that makes sense. How do you see the future of GGIR? Which way you see it going? Will there be like Is there already now for different age groups, and how much do you have variability for different age groups or maybe patient groups, different algorithms?
As it is open source, it means that it can grow as much as people want it to grow,
Mm.
but it doesn't mean that it's easy to make it bigger or make it or include new functionalities in it, because I mean you need that people are aware that the time you invest in GGIR, it has a value, and so it's not, you cannot expect everyone collaborating in GGIR and not receiving anything back. So it depends on the community, I guess. If the community mm, is aware of that this work is needed, that we need to work together to get better software, and open source code is a great opportunity for that. So GGR will keep evolving. And I think at the moment, Vincent is doing a great job for that. So he's trying to make everyone aware of how hard it is, or how important it is to keep developing the software, and that we all as a community should invest our efforts in that.
Mm. Yeah. And earlier you said that mainly you have sleep detection from the wrist, and then for the activity and sedentary behavior you have hip or waist. Do you have any plans for the thigh-worn accelerometers to develop code for those?
Yeah, I meant that the wrist detection that we have implemented, so the one that we have implemented for the wrist is validated, and Vincent has several papers explaining and validating these algorithms against polysomnography. I know he was now developing some code to get some sleep estimates from hip, but I think these algorithms are not validated yet. So it would be great if anyone can do a study with the hip-based estimates of GGIR for sleep, and and the and their accelerometer data. And even if anyone has polysomnography data, that would be great, that they get to validate these algorithms to know how good are they. And for the physical activity and sedentary behavior part, we mainly use the cut point approach. So it just we don't have we don't say that it is specific for hip or for waist. It depends on the cut points you included, if they have been validated in hip or waist or so. So at the moment, we mainly rely on this cut point approach. So it makes GGR that is not location specific. So if you have cut points for thigh accelerometers, you can use them within GGR. What we don't have is an estimation of the posture from the angles of the accelerometer for physical activity. I mean, to differentiate between sitting and standing and so on, as many software based on thigh accelerometer have.
Mm. Yeah, so mainly doing it with cut points, and do you do it same way with the sleep? Is it still cut points, or how do you analyze sleep?
No, the sleep part mainly relies on the angle variability of the accelerometer. So the default code looks for chunks of data in which during 5 minutes the angle of the device varies less than 5 degrees. So if that happens, it's likely that the participant is sleeping, and then it applies some post-processing steps to decide if it is sleeping or it is inactivity bound during the day.
Mm. Yeah. So what kind of collaborators you are looking? You said that it's important that this work is done, and you have an active community. There might be some listeners who could be interested joining. What kind of people are needed, and what they should do if they want to join?
Well, anyone interested in physical activity who have some coding skills to develop the code further, so they are welcome for sure. They just need to go to the package repository. It's in GitHub, and there they will find all the codes for all the functions that we use in GGR. They will find some issues so the issues are mainly the things that we post that we think GGR should improve in something or should include a new functionality. So if anyone has a proposal, they can post an issue there, and they can also work on the issues that are already there. So you just need to go to GitHub to the package repository, and then you can start collaborating. And that's it. I mean, anyone is welcome.
Yeah, sounds good. So I think we will finish the part one here. So it was interesting discussions about the GGIR, and in a moment we will continue with part two and talk more about physical activity measurement with accelerometry and other interesting topics. So thank you, Jairo.
Thank you so much, Ali.